So yeah, as mentioned, welcome to the Tech Talk number 2. We have a nice agenda today with 2 interesting talks. So first of all, we will get some overview and introduction from Pierre Gronlier, the CTO of the Gaia-X AISBL, about the Gaia-X compliance and labels. So I think it's a very important topic for that context here, about which I will talk very, very briefly also in a moment, just to give a reminder to all of you what these tech talks are about. And on the other hand, we will hear from Vogel from Informationssysteme a presentation of a very interesting use case centered around digital twins. And yeah, in that context in which we are here, this is as well relevant. So what is this context? Well, these tech talks have emerged from our discussions that we had about the IPSE project last year and during the last months as well. So we have created a strong partner network and developed together a proposal for the IPSE with many of different European companies. And in that context, there was the idea and also some interest to have a consistent format that is related to that project that we have developed and that we also have handed in and with which we have been successful also so far in the process to bring together people talking about aspects relevant in the context of digital sovereignty, relevant in the context of sustainable digital infrastructures, and relevant in the context also of federated infrastructures. And in that overall context, we have developed this tech talk format, which we are piloting currently. So if there's really interest and not just a declaration of interest. So we had so far a first event nearly a month ago. And now, we have the second event and are very happy that, we have also that strong support from different people who are ready and eager to give presentations. So actually there are far more options to select from than we thought so far. So thank you also to those who have handed in something and proposed some talks. So if you have further ideas, for sure, that should not stop you to propose something. And we will always select 2 talks also for the next events that are related to what I've just mentioned, so to the overall umbrella of digital sovereignty for Europe. And we'll select from the proposals and set up that format continuously during the next months. Also to create some network in general that is centered around that IPSE. And to also help to spread information about different interesting initiatives, always with a technological focus, definitely, that's important, that are relevant in that context of the IPSE. So for example, that could be some initial technical concepts, that could be implementations, it could be as well very important initiatives such as Gaia-X. So we will get that overview in a moment. But also, for example, as we also hear today, use cases that are relevant in that context, and as well NNP also participates in that IPSE. It's definitely worth looking at the use case to also identify maybe first ideas for requirements and so on in that context. So that's the overall idea here, to have a broad spectrum of discussions of topics that are relevant in the mentioned context, and to bring together people interested in these things and to spread knowledge about these initiatives and about the different approaches that are presented here. One formal remark, so the tech talks are open to everyone, which means, if you have any sensitive information, for sure, be careful with it and, keep it on your side if they should not be publicly available. The talks will be also recorded and we will spread them as well. This means you should, as I have mentioned, be then careful with sensitive information. Yeah, it's also mentioned, drop us an email. Maria is doing the background work mainly. And that's also the overall organization. I then just get that set of slides here that Alessia has created from our side and present these things. So there's a team behind it, mainly consisting of Maria as well as Alessia, who organize the overall event. Yeah, with that I think we can start. So the two presenters can just, well, take the right to present, and we'll start with Pierre. Pierre, the floor is yours.
Thank you very much. Just launching the presentation in full screen, sharing my screen, and I will be ready. Here it is. So thank you very much for having me. I'm very happy that you thought about me for that deep dive and technical presentation. So even if this is a technical presentation, and I know that there is a Q&A, so I'll try to go through the slides quickly and then favor more the questions, but still try to give enough information so it triggers interest and questions. Gaia-X was created about 3 years ago, coming from an overall observation that we want to make Europe a leader in AI. Leader in AI requires data and software. We focus mainly on the data, but software is also very important. So to have data for training AI algorithm, you need to be able to exchange that. And that's where this idea of data spaces and being able to share data came into motion, and the creation of Gaia-X. For exchanging data, we want to adhere to some principles from the European values that are self-determination, transparency, and confidentiality, security, and so on. I see that there is already raised hand. I don't know if you would like me to wait for the Q&A or...
Would be great to wait for the Q&A.
Okay, so I will follow 10 minutes and then I'll take question. So that was the only slides that were a bit high level. Now, when we talk about European sovereignty, I prefer to talk about level of autonomy. Sovereignty is something that policymakers, sovereign, can take action on. As individual, we can take care about our physical integrity, or as natural legal entity, we can take care of our level of autonomy. And we have mainly two categories of autonomy, the technical one and the legal one. For the legal one, I will include everything that falls under document, extraterritorial law, contracts, KYC, consent management, any type of regulation, and that will be usage control. On the technical autonomy, we have two subclasses, the hardware one and the data. For the hardware, there are other initiatives in Europe that take care of that. For the data, and I'm including software and data sets, so analytic data, we can control that using both access control and usage control. So access control is who am I giving access to. Usage control is what am I allowing the others to do with the data or the software just exchange, because that's the same thing. Software has also a copyright, have also copyrights and license rights. So usage control. That's what we will call compliance or Gaia-X compliance, everything that is in blue. And when we think about compliance as a developer, the first thing I could think of was conformity assessment body or certification, something that looks like that. And that is something I wanted to avoid for Gaia-X, because Gaia-X is, first of all, a European initiative that promotes European value. So that's not bounded only to European economic area. And we have in Europe a lot of SMEs. So if we are not able to onboard small, medium enterprise, our European economy will be at risk. So we need to make sure that this compliance doesn't come as a burden for SMEs. So for this presentation, I started to create new slides. So you will be the first one to see those slides. You might have seen this big X before. So data ecosystem, infrastructure ecosystem, and a big now a red label that is saying deprecated. That was the X that we had about 2 years ago. So I'm just going to clean that up a bit and have a new version. First, we don't talk about data ecosystem and infrastructure ecosystem, but data services and infrastructure services. Data, we're able to share, to transfer, to process data because we have infrastructure. And we do have infrastructure because we want to share, transfer, and process data. One lives with the other. We cannot really split them apart. Doesn't make much sense. The second thing is all those data spaces or domain, they are not living only in the data services. They all have regulation. industry or finance relies on infrastructure that must fulfill some requirement on the infrastructure level. So they are more like that, in fact, across the two part of the X. And now I'm going back to a picture that you're probably aware of. No, that's the definition of the Gaia-X ecosystem. Gaia-X ecosystem, that will be all the entity defined inside the architecture document. So many participant could be provider, consumer, federator, service offering, type of resources, physical resources, virtual resources, that fulfills the rule of the trust framework, the Gaia-X compliance. And I will come to that and present that. So here I have the same boxes I had before. So energy, sector, finance, health, and so on. Those are ecosystem or data spaces. They all have existing service, existing data set there. And now I'm realizing that the color is a bit flashy, but those are the original one. Those are finally the same X, the same core services that you were seeing before, but in terms of 3 layers. So the trust plane, the management plane, and the usage plane. I've described those planes in a previous video, which is available on YouTube. So I will probably not spend time on that, and I will link to that online resources if required. The important message here is that we have existing ecosystem, and for those ecosystems to be interoperable or to be able to exchange data, we need to have a common governance. And that's what this Gaia-X compliance is about. That's the minimum set of rules that everyone has to fulfill in order to be able to speak the same language. And the example I'm giving usually on that slide is the trust plane that will be like the passport. Each country is a sovereign when they issue the passport, but all the country agree to use the same vocabulary: a picture, issuance date, a name, first name, expiration date, and so on. Then you have the management plane. That's when you enter an ecosystem, and then it's like applying for a visa. You need to have additional regulation. And the management and the usage plane, that's really the technical interoperability. So if you go to the US, that's 110 volts, 60 hertz. In Europe, that's 240, 50 hertz. So those are not interoperable, but because we are using the same vocabulary, volts, hertz, amp, then we are able to build converters, bridges, gateway. So it's only because we are using the same vocabulary that we are able to have portability and interoperability. So before we address the technical interoperability side, which is very important, that's bottom part of the X, so that's still there and existing, we need to have a common governance. So usually when I'm doing that in front of an audience, I'm asking by raise of hand, who is familiar with infrastructure as code? I cannot see raise hand right now, but I will imagine that some of you are aware of that. Imagine that now you can do compliance as code. So the same thing that you had with Terraform, Ansible, Chef, Puppet, when you write your code or your network for your network segment, security group, VM, load balancer, storage, you could do the same thing with compliance. And then compliance as code, that's really what we aim at. Finally, part of the label and trust framework. So where does it fit? We have in Gaia-X an overarching document that we call the policy rules document, that is a high-level statements about what are Gaia-X values. This document gets translated into 2 subcategories: the trust framework and the labeling framework. The main difference between the trust framework and the labeling framework is that the trust framework is only about measurable and comparable attributes. It also makes that compliance compulsory, so mandatory. The labeling, that will be optional, and that's an additional layer of information or an easier way to read it. And an analogy that I'm using, but this time with picture, so that's also the first time I'm using that here. It will be the equivalent of the trust framework, that's like this nutrition fact or the list of ingredients that you have in food packages. So every package has that, but you need to understand what is E101 or some like food colorant and what they exactly mean. On the other side, you might have seen that Nutri-Score in some food packaging in Europe, where it describes, that tells you how healthy food is. Well, labels can be seen as the same way. That will be like the Nutri-Score for services and data, for cloud services and data. I will start with the label. So the label has a higher level of reading, and we have one Gaia-X label with 3 levels. The label framework will have to introduce three new rules: the rules of the label owner. In that case of the Gaia-X, that's the Gaia-X association, which is the owner. The label issuer, that will be still the association that will issue the label, and the label verifier, or the verifier. And the verifier might be some other third-party organization. Here, for example, we are mentioning ENISA. So we might delegate the verification of some of the property we're looking for to ENISA, or to some of the European Data Protection Board acknowledged code of conduct for GDPR, and or any other monitoring bodies for specific attributes. Usually those steps are manual and a bit expensive. The trust framework on the other side, that's really, again, SMEs are really at the core of that framework. That's to show how we can compose offering of SMEs together. And we want to build this knowledge graph of verifiable credentials, verifiable signed claim, where we compose services together. So on the bottom right corner of that slide, you have a data pipeline, some mobile phone that submit files, and that gets aggregated into the cloud, maybe some cleaning of the data, training, and we have a machine model that we can store on a database. That's something that every organization knows how to do now. Imagine that you want to do that, but across organizations. So instead of having one pipeline, you have the same pipeline, but across. Here we have 6 icons, 6 on the top, 6 at the bottom, so 12 different providers. That starts to be very complicated if we have to review every time different terms and conditions, different end user license agreement, copyrights, and so on. The idea with compliance as code is that we adopt a common vocabulary for expressing those. So the same way when you go to the hardware store, you have all those chemical bottles. You can use the chemical formula for acetone, rice spirit, terebinthine, and fuel, and other things. I'm not sure how to translate that in English, sorry. But all those bottles have those small pictograms saying that this is toxic or corrosive or explosive and so on. So they come up with a vocabulary that says those are the main attributes that you should watch out. And that enables us to, even if you are not speaking the language or being a master in chemistry, to understand the product, how to handle the product properly. That's the same thing if you want to enable service composition. We have to agree with a vocabulary. That's maybe some of you are familiar. It's like we are creating in Gaia-X a domain-specific language for compliance and service composition. And the last slide about the trust framework, it's going to give you an example of a really concrete rule between the difference between trust framework and labeling. One of the rules that we have in the trust framework, so that will be at the 2 columns at the bottom of the slides, is that every service offering must have a provided by attributes that links to a participant, and every participant must have a legal country of jurisdiction. So where is the company registered? We are not taking a decision whether or not the country is good or bad. We are enforcing the information to be there. On the labeling side, that's what we will call first order logic rules in opposition to the second order logic rules of the trust framework. Labels will put criteria or thresholds on the value of those attributes. So for example, someone wants their services to be non-subject to non-European law. Then they will have to make sure that their services are provided by provider that are based in EEA, European Economic Area. Lot of text, not so much code, I know, but we do have already 2 API that are up and running. So the first one is compliance.gaia.eu. The second one is registry.gaia.eu, where we are building really the API endpoints where you can take those rules that are part of the trust framework, by the way, which is published since last week. So if you go on the Gaia-X website, you will have the trust framework document, the latest version. You are able to issue verifiable credentials, so small JSON file, nothing really highly complex, and submit that to the compliance and get back in return a verifiable credential signed by the association that says, this is a Gaia-X compliant participant of service offering. For now, we are starting with participant because it's a bit easier to implement. And as soon as this is correctly shaped and working, then we will move to the service offering part. thank you very much. I hope that was digestible, given the time, and really main takeaway will be, yeah, compliance as code is something I'm trying to promote now. I think it makes a good idea of, well, for developers who are familiar with infrastructure as code and exactly see what the benefit of using infrastructure code, hopefully they can see the benefit of compliance as code.
Okay, thank you, Pierre. Yeah, questions? Anybody? There was one question during the talk, I remember. So
yeah, I don't remember what was the name of person.
I think it was Danilo who raised his hand during the talk, but maybe it was a mistake. I don't know.
Michael has a raised hand.
Yeah.
So it's me.
Yep.
Okay. Yeah. Thank you very much for the presentation. So always happy to hear what's going on and what's developing for Gaia-X. So please, one question. I've understood that Gaia-X is not taking care about hardware. So as I have understood it on your first slide, so there's a separation. You have the software and you have the hardware, and this is separated. And Gaia-X is only taking care of the hardware side, of the software side. I mean, yes. Trust. So I try to think through this. So trust to define and to enforce and to execute compliance and trust. I think you need the hardware, at least for certain for testimonials. So it's difficult for me to understand this, how you want to guarantee trust without having your hands on the hardware as well.
So the software will require hardware. Where I'm making the difference is Gaia-X is not building hardware. When we talk about building new hardware chipset in Europe, we have other initiatives in Europe that do take care of that. That's the distinction I wanted to make. Of course, if you want to have the data located in Europe, you need to be able to go down to the hardware side. If you want to have some special technology, trusted execution enclave, you will be able to describe what is your hardware. So describing the hardware is part of the scope of Gaia-X. Building hardware is out of the scope of Gaia-X.
Okay, thank you. It makes it clearer to me. Thank you very much.
Yeah, further questions? If not, I have one.
So that was really the difference between infrastructure, physical devices, and in the data, there is a small box that says infrastructure as a service, which is part of Gaia-X, but not the bare metal servers. I mean, we are not going to build servers our own.
No. So, I mean, you also have followed the IPSA initiative, I guess.
Yep.
So, which role should Gaia-X play in your opinion? I mean, an important role, okay, but maybe also a little bit more in detail. Is there any very concrete, structured approach to integrate the things you have discussed in the IPSA context? So maybe you can give some insights into that topic as well.
We are just started. I mean, the IPSA is a project that has been, I know, started some time ago, but the first tender and the first piece of work have just been started now. So we are working with some of the winner of the bids on how we align. One thing which is unique in Gaia-X that we don't find in the IPSA is this governance and the common digital governance. One other thing I've shown and the slides, in the very flashy slides with greenish color, that one, I will take care of the colors later. We do have existing ecosystem. We do have existing data spaces or federation. If you take Fireware, if you take ADSA, if you take EOSC, if you take any or even a proprietary solution, I will not mention some now, but we do have existing proprietary technology that enables few stakeholders, participants to create their own ecosystem. What they don't have is this common governance that says, I am able to find a contract and enter into a contract relation with another ecosystem without spending months and paying an entire legal department to review the contracts. This is really something that we are trying to address now by easing negotiation or the governance, then I strongly believe that this is a key success factor that will unlock exchange between SMEs, and this is not part of IPSI. So I believe that this is something that Gaia-X could bring that to IPSI.
Okay. Oh yeah, you have a question?
Yes, thank you very much. I was thinking about this example with the ingredients and the Nutri-Score, and I was trying to figure out how this would work, because Gaia-X is going to develop the trust framework and the labeling framework, I understand, but how does the step towards the policy work? So you need to enforce this somehow.
Yes. So if I take, for example, the thing about the Nutri-Score here as a mandatory, I will see how much fat, sodium, and sugar you have in your package. If I go and take the trust framework, I have it here. And for example, the presentation for self-description for a participant, I will see some mandatory attributes that are registration number, headquarter country, legal address. There are other examples for service offering. Service offering, depending on the type of service offering. For example, here I have a data connector like EDC. We want to enforce that, well, if you have a data connector, you need to be able to specify where the data is. So you have at least one physical resources and who is providing the data. So at least one virtual resources about the data which is provided, and a set of policies, and preferably a set of computable policies. That would be the way we enforce. So if you have a solution and you just describe that, you can then go to the Gaia-X compliance services and get back a signed claim by the association saying that this is legit. The first version of the service, this is, I know, central. So there is maybe 3 iterations we envision. The first one, because we want to start quickly, that's centrally operated by the association, which I know is conflicting with the statements that we say that the association will not operate services, but we have to start somewhere. We want to do very soon, hopefully by the end of this year, to have that distributed across federators. So this isn't the association doesn't become a silo anymore, and we don't want to become a bottleneck there. And the third iteration that we envision, but for the long run, I would like to have that completely decentralized. But that brings also some question about sustainability of the model. Who pays for an infrastructure? Do we need to issue coins and so on? And that brings open a full kind of question that we don't necessarily want to address right now. So first version centrally owned by the association. And if you are a user, so you are a user and you want to make sure that your services is Gaia-X compliant, you will verify that the description has been signed by the association. If this is not signed by the association, then this has not been going through the Gaia-X trust framework process validation process. So that's how we enforce. Basically, we trust the customer to watch out for what he's consuming, because at some point we have to realize that we cannot enforce people to adhere to a behavior. I mean, this is like the trust framework. It's like the Nutri-Score. If I want to eat burger and pizza every day, I can. This is very unhealthy, but I can. It's similar to Gaia-X. We want to measure, we want to provide metrics that create more transparency and comparison. I truly believe that one of the added value there is being able to compare. When we enforce, for example, that the service offering has a privacy statements, a 12-page long privacy statements in full English, I will not be able to compare it with another privacy statements of maybe 25-page long in plain English. It's very hard for me. What matters is what are you going to do with my data? And looking at all the scenarios, there is probably 10 to 15 different type of scenarios for data. Can I share it? Can I sublicense? Can I use it for commercial usage, for research usage? Yeah, there is a limited number of use cases, in fact. And by being able to compare them, that will make a life for the people who, the stakeholders that consume the services much easier, and say, okay, I can consume that because I know that this is what I allow my data to be used for, or how that should be used.
There's one question in the chat. That should be the last question because we have to proceed with the second talk. So, Markus, maybe you want to briefly raise it?
Okay. It's all about getting prototypes onto the street. Is the complex DITCOM also a channel necessary?
I don't have that answer to that question.
Okay. Yes, in some specification, there's a link to Hyperledger, Indy, and ARIS. But to keep it plain and simple, okay, then you still can use a DNS or something like this, or have this locally. Okay.
We are not forcing any type of verifiable registry. Or support. It can be DidWeb. That's the one I'm using, and the lab, the Gaia-X lab, is using for all their prototypes. If someone used to use DNS, which is not yet available, if I remember correctly, then maybe not. Yeah, on Ethereum, on Ion, why not? We are focusing more on who is validating that DID. So again, more on the compliance side or the governance than technically speaking, where is the DID stored. Those specifications about DID, DITCOM, and hyperledgers come from the specification that were created and written down even before the Gaia-X Association was created.
Okay, understood. Okay.
So
Gaia-X needs to be updated.
Needs to be updated. It was maybe one word on GXFS and Gaia-X. Gaia-X Association was created. The first time Gaia-X project was mentioned was end of 2019. But the association was fully created, registered legally in February 2021, so a bit more than a year. However, the GXFSDE, so the German-funded, national-funded project, started mid-2020, so a year before Gaia-X was started to be operational. So GXFSDE specification can be seen as a great Kickstarter for the spec, because we had nothing and we had to start from somewhere. But what we are doing now is that, well, the architecture of Gaia-X changed significantly in some area, and we need to update those specifications. So I will not push, for example, specifically for Hyperledger or any specific tech. I'm caring a lot more on where is that DID from, who issued that, and based on which principles, which on-based rules. Because generating a DID, I can do that easily. You probably know how to generate a DID. That's not rocket science. What matters is how does it enables me to measure risk, to make a risk assessment.
Okay, I don't want to interrupt. Yeah, it's that interesting discussion and the question session. However, I have to, as we have another talk. So thank you very much, Pierre. And I think it's really important also to, during the execution of the IPSE, to check also the things that evolve during the next months in the context of Gaia-X, always with a clear reference to the Gaia-X AISBL. So, as you also mentioned, yeah, there are different initiatives. Also in the past, there have been a lot of initiatives that claimed that they have already done all the work and so on and so on. So there's one ground truth, and this is defined by you and your team currently, and we definitely should stick to that also during the IPSE execution, and should check, as I've mentioned, updates during the next months. That's crucial, and I think would be also very very fundamental to integrate these things in the IPSE context. Yeah.
Thank you very much, and thank you to Cloud&Heat for all the support you are providing.
It's a pleasure. So thank you for your presentation, and we move on to a use case that, well, will have some relevancy in the IPSE, hopefully. So Marco, the floor is yours.
Thank you very much, Niles. Just so can you see my screen?
Yeah.
Okay, first of all, also thank you very much for being able today to present you some aspects on the digital twin. Maybe almost nobody knows me, so that's why I should like to shortly introduce myself. My name is Marco Vogel. I'm working currently for the business development department together with Björn Schuster at NNP Informationssysteme GmbH. Yeah, basically, I'm a mechanical engineer, so I'm not an IT expert itself. And I've been working for almost 20 years in the frame of aerospace and automotive systems engineering methods. And I would like to give you today a short introduction, a brief introduction to the digital twin definition and some use cases which we are focused on in our company. Okay. First of all, maybe as a summary, what are we doing? As you can see on the right side, in form of a railway system, our focus is the IT system integration of the two main domains of product and building creation process, with the phases design, manufacture, and service, or plan, build, and operate. As you can see, we focus on different IT systems. And see this as a, like I said, as a system integrator. As you can see, there could be different ways on the journey of different companies how to integrate system, because the requirements are quite different depending on the size or on the domain of the company. So we could go a short way or a longer way through different stations and combine different systems, which is the target, to have such a efficient value stream there. All right, what is our offering? IT consulting, IT development, IT implementation, and also the managed service behind the systems. Okay, this I can maybe overgo there. We have 30 years experience, 7 offices, and our headquarters is in Merane in Saxony. Again, the two main domains which are we focusing on, and which will be also led over later to the digital twin, and why we are selecting special use cases for this digital twin. Like I said, we focus on the first step of the product creation process and the associated systems. That means we have some proprietary systems which we are developing ourselves. For example, the MES system, Noob MES, but we are also using partner systems and working together with them. And all these building blocks we are using to combine them along the complete value chain. The same for the building creation process. There we have our proprietary system Spartacus as CAFM system, and also then the backbone with the IT service for conception, implementation, and also for managed services. All right, that's maybe shortly the introduction. Now you could ask, okay, why are telling you something about value chains or digital transformation or whatever, or value stream connection? That's why this is all the basis for later also the digital twin. Like I said, on the two main domains, product development. Sorry, is there a question? Well,
I think someone had their microphone open.
Okay, okay, no problem. Okay, and the building development process. Okay, So now let's come to the core, and that's also why I was talking about the subsystems or processes on the way to the value stream or around the value stream, because this is very important also to get the definition of the digital twin, or our definition. I know there are quite a few definitions or use cases around this topic, but we selected 4 of them. But generally, the definition of the digital twin is always to have, first of all, a real product. And this is also the difference to some definitions, because some people think, okay, I have a virtual representation of a product in form of a 3D model, and this is my digital twin. But this is not the whole story from our point of view, and also from some academic point of views, because you do not only need the virtual representation in form of documents or a 3D model, but you also need the connection to the real world. That means only if I have a real product, a physical product, connected with sensors to the digital world, and then also the interaction between this physical world and this virtual world, then from our point of view, you have this digital twin and the associated use cases. Based on our main domains, which we are focusing on, means product and building, we selected 4, I would say, types of digital twins, which we are dealing with, and where we also select the different use cases or focus on these use cases. The first one is the so-called smart connected product, means the digital twin of a specific product. It can be a machine or any other asset, whatever. That means the target group is here the machine manufacturer, and the object would be then the sold machine in operation, associated with all these services, which can be in frame of use cases, for example, predictive maintenance or whatever. The second one is the so-called smart connected technology. This is a digital twin of a production process, for example, of a milling process. That means you can capture operating parameters, milling parameters or whatever, to get, for example, the documentation or quality documentation of the manufactured product. For example, a milling part. The use case here would be, for example, to fully digital document your quality instead of paper, which is really important, for example, for safety relevant products for space or automotive, where the OEM requires these documents. But the opportunity here is also to digitalize them based on this digital twin. The third one is the so-called smart connected shop floor. That means you can combine different machines in your production line and then build the digital twin of it. And the fourth one, maybe imagine around your shop floor, there's also a building. That means we have this so-called smart connected building, which connects the real world of the building with also the virtual representation. For the second and third bars in this illustration on this sheet, like I already mentioned, it's very important that the digital twin does not start at the, I would say, upload of a 3D model, but you need to consider the complete value chain, because the representation or the virtual model, it does not or is not created at the starting point of this digital twin representation, but it's developed through, for example, the design and manufacturing phase. And all this information must then be included into this digital twin. The same for the building design and build process, or the so-called BIM process. And our advantage is that we do not only connect these IT systems, but we also have this expertise on the domains itself. That we can also consult in the manufacturing or building operation processes. Basis for all, and then we come also to this IT topic. We need the secure and efficient IT infrastructure, especially for the new systems which are mainly cloud-based. but which also need the connection to these business applications. Okay. You can see the digital twin maturity levels. That means it's not a kind of from zero to hero philosophy, but there are different stages where you can see that there are also different types or stages of the digital twin, also based on the digital transformation. That means, as you can imagine, a lot of small or mid-sized companies are not fully digital transformed today. They are on the way, partially, but they are not fully digital transformed. There's also a myth that, for example, the descriptive part or stage is not really the digital twin, because this is only the basis, means this is the so-called 3D model or other information from the virtual world, from the development. But as I already mentioned in the definition, this is not really the digital twin because the physical or the connection to the real world is missing. And the actual main focus for these small and mid-sized companies is now, from our perspective, to get into the first step to have the informative digital twin. That means to create transparency, collect data, and visualize the data from the real product. This is the first step. And then, as the basis, if I have this data, I can use them in form of a big data or IA concepts to have this predictive topic, or also the comprehensive, or also the autonomous digital twin. But from our point of view, this is the visionary or pilot stages for the SMEs, because we are currently, from practical point of view, at the first steps. For sure, if you go further, the business value also increases then. Okay, maybe an example where you can imagine that you can combine a smart building and also a smart factory. As I said, the building around the shop floor, or is this factory, but it's a kind of building. The starting point here would be, I use the so-called building information model, which contains the 3D model of the building, but also the 3D model and also all documents or metadata of the technical equipments within the building. And you can upload it into the, or for example, into our platform, which is acting as an entry point, also called single pane of glass, where all information from the virtual model and also from the real world, meaning IoT data, like I said, combined and then managed here, visualized. And this could be also the starting point to trigger further process steps or process actions, depending on what I want to do with this data. For example, reports or notifications in case of deviations. And then we come to the connection to the business system, for example, to a CAFM system or to an MES system or whatever, or also to an ERP system, which is normally connected to an MES or manufacturing execution system, which is the, I would say, core system for the process itself, either on the facility management or also on the shop floor system. This could be a possible scenario, generally high level, how you can, or how these different topics play together. Okay, maybe some insights of the factory, or what is the main focus of the smart factory. First of all, for sure, like already mentioned, I'd like to get or create transparency and optimization of productivity in the shop floor. It's possible to reach a real-time monitoring of quality, efficiency, and the production progress. Can have a connection between production planning and control within the shop floor. This is the connection from the MES system to the machines themselves, and all advantages which are reached of this. For sure, I can also reduce carbon dioxide emissions and reach the sustainability. And I can also create a 360 degrees view. That means the single source of truth. Important here is to know that I do not want to duplicate data. As you can remember in the slide before, when I upload models or data into a platform, I do not want to duplicate information because then I always have the risk that they are not synchronized in case of modification. But I'd like to just create, for example, a kind of link and keep the data or the initial data where they are created. This secures also to always have the newest information. Yeah? Nothing is worse than work with wrong data or wrong information. That's why the single source of truth philosophy is very important here. Okay, which opportunities can occur here for the digitalization in a smart factory? Just a selection. That means, as already said, I can perform the condition monitoring either on a product. It means a machine within the shop floor is kind of smart connected product, or I can also monitor my complete, for example, assembly line or manufacturing line. I can alert the service technicians in the event of equipment failure. When I have these data, I can also detect patterns or anomalies. Next topic would also be the energy monitoring and management, very important topic today. We also see that even if I connect the machine with the energy module and I monitor this, there can be a lot of advantages and efficiency increasements in case of doing this. Connected worker is also a very big topic because the type or the I would say tasks of a normal, I would say, shop floor worker will change in the future because he has to work with digital media and also with the data which are created out of this digital twin. And one topic could also be the indoor navigation, including the navigation of AGVs or how it's called, AMRs, means autonomous mobile robots within the shop floor, which are also a big trend today, just to increase the efficiency of my factory. Okay, last but not least, maybe all of you know these mega trends. I think I do not need to explain them all, but these are always the triggers for all the use cases which we are also focused on, because these are, I would say, the headlines for us, and then the use cases come or follow these headlines. Same for the new digital services, for example, for building. That means reduction of energy consumption. Then, for example, also the automatic notification of building technicians in case of failure. Indoor navigation already mentioned. Display of free parking spaces or avoid false alarms, reconciling data, and so on. I think, like I said, I do not need to explain them all. Because they are all known, I think. All right. That's all from my side. Like I said, brief introduction to our philosophy and use cases for the digital twin. If there are questions.
Yeah, thank you very much for that overview. I definitely have at least one question, but maybe from the others first of all. Are there questions? Do not see any raised hand. So, I mean, in the IPSE, we plan to create an edge infrastructure and a cloud edge continuum. So, why do you need such an infrastructure exactly with that use cases? So, and which concrete requirements may you bring to that context?
Yeah, the requirements, I think, are then derived from the use cases. For example, if I go back to this slide, if you can imagine that's such a smart factory, For sure, we need to capture and to transfer the information. Yeah? That means, for example, if you imagine you have a machine, a milling machine within your shop floor, there could be different scenarios or requirements. First of all, for the maintenance, it could be that the manufacturer organizes the maintenance or wants to organize the maintenance or wants to provide a service for the maintenance. That means he needs to receive its data from a factory from, I would say, all over the world. From practical point of view, that means you need to collect the data and also transfer them to the manufacturer, and this also needs then the appropriate infrastructure for sure. Okay. Because the machines are distributed to different locations.
Yeah. Okay. Yeah. Further questions? Yeah. 2 minutes left. So doesn't seem to be the case. Then thank you very much for giving some insights into these use cases. And yeah, I think and hope that we will hear further things in that context then during the next years of execution of the IPSATE project. Yeah, so with this we are through the agenda. Already one important announcement. There will be a third tech talk, which will take place on the 30th of June. We are currently compiling the agenda, but yeah, we think we have identified quite interesting talks there. Again, or combination, definitely. So some overall initiative on one hand, on the other hand, some technical details that should be presented. So yeah, would be great if you join on the 30th of June at 2 p.m. again, and also beforehand, make some advertisement for that event, and let's see what we can then expect next time.